Hey everybody, welcome to the second of 6 lessons in Science 24, Unit A. Again, my name is Mr. Adamson, and this lesson we are going to talk about plastics, polymers, and alloys, and we're also going to talk about chemistry at the home. So first thing that we need to do is do some definitions here. Now the first one is polymers, and what are polymers? Well, polymers are a type of compound that occurs in nature. So for example, silk and spider webs and sap from rubber trees. Synthetic polymers, though, are man-made, and so they are called plastics. So another word for synthetic polymers are plastics, and these are beneficial because scientists can develop different plastics that meet the characteristics that you need. I mean, if you're using a computer right now or you're using your phone, think about the case, think about what's inside of it, think about the cup you drink of. I mean, plastics can be made into a variety of different things that we use for our daily lives. So just some examples: neoprene with wetsuits, polyethylene, these are milk jugs, polystyrene, styrofoam cups, and polyurethane, this would be clothing. Synthetic polymers also help you see. You're saying, what? How does that happen? Well, the lightweight lenses in eyeglasses are also made of synthetic polymers. And what are alloys? I know you were asking yourself. Well, alloys are a mixture of different types of metals that contain the properties of each of the original metal. So many of the products that are used today are made of alloys. Long ago, cooking utensils were made of iron, which eventually rusted. Modern kitchen utensils are made of an alloy that looks like one metal, but does not rust. Similarly, the steel in today's cars are made of an alloy of iron and chromium. The steel alloy has the strength of iron, plus chromium's resistance to rusting. So just before we go on there's a few definitions, a few examples of what polymers, synthetic polymers, and alloys are. Useful to know as you move forward. Now, next thing that we want to talk about is chemistry at your home. So how is chemistry happening if you think you're sitting right now on your couch or whatever? How does chemistry happen at home? Well, first thing we have to think about in our cupboards, we have a lot of different hazardous and harmful substances actually found. Go to your kitchen, go to your garage. Now, the first thing that we need to be aware of is the HHPS. So if we look right here, HHPS, and what does that stand for? Well, that stands for the Household Hazardous Product Symbols. And these are safety warnings that are designed to be easily understood and are found on these hazardous substances. So HPPS symbols are danger. So right here, this red octagon means danger. This orange triangle means warning. Sorry, that's a diamond, not a triangle. And then the last one, this yellow triangle, means caution. So danger, warning, caution. Then we have symbols to go with inside of them. We have the skull and crossbones, that means toxic. We have this explosive, looks like something's blowing up. Again, it's explosive. We have this, you see, looks like your hand inside something. It almost looks like you can only see the bones. That means corrosive, so it's eating away at the skin. And then this last one, this fire-looking structure, that is flammable. The drain cleaners, such as Drano, for example, often contain highly corrosive substances such as sodium hydroxide. Bases like sodium hydroxide help clean clogged drains by breaking down the proteins, so skin cells, hair, all those things that get dumped down your drain, and giving off heat to melt the grease. So if you have Drano right now, these are the symbols that you would see. And you're probably saying, well, what do those mean again? Well, what does this red structure mean? Well, that means danger, corrosive, danger, toxic. So again, what does corrosive mean? Well, it means it could burn you if you get it on your skin. Toxic means don't drink it. It could be poisonous. Next one, chemistry and cooking. Yes, there's a lot of chemistry in relation to cooking. Well, a knowledge of chemistry is important to chefs, bakers, and cooks. Okay, knowing how different ingredients react allow you to control chemical reactions. And you're probably thinking, well, what chemical reactions happen when I'm cooking? Well, for example, yeast is what causes bread to rise. I don't know if any of you ever made bread. I did the other day in my bread maker, forgot to put in yeast. What happened? I just got a big lump of soggy flour, really. Yeast is a single-celled organism, which when warms in a moist environment, so moist dough in an oven, yeast converts sugar and starch into carbon dioxide and alcohol, and this makes bubbles. This is what causes the bread to rise. And there is some examples of chemistry at your home, along with what we talked about with polymers and alloys, and you can kind of have an idea. Yes, chemistry is all around us. It's with everything we use. It's when we're making food. I mean, in your frying pan, you have chemical reactions in relation to butter if you throw it in there, or oils. So, I mean, it is something that's all around you and good to know about. Hopefully you're able to get something from this lesson. And thanks for listening.